Okay, welcome back everybody. We are now going to start Chapter 2, Section 4, on graphs that enlighten and graphs that deceive. So we've learned a little bit now about frequency distributions, which can be used to make graphs. We've learned about one type of graph called a histogram. And now let's talk through some other types of graphs that you may see. Okay, so there are, again, the key concept here is that there's a number of different types of graphs, and this is going to be a brief introduction to kind of the pros and cons of each of these graphs, a little bit about what they're used for, not so much a lesson in how to actually construct them. But again, for the most part, you use technology to construct any of these graphs. Okay, so again, the objective here is that when you're looking at your data, you need to identify the most suitable graph. So the graph needs to be effective in revealing the important things that you want your reader or your viewer to take away from your data. And so as we're going to see, different graphs have different ways of displaying data, and based on that, they kind of lead your viewer in a different way. And so you want to be strategic as you're selecting graphs for your data. Okay, so the title of this section is Graphs That Enlighten and Graphs That Deceive. So let's talk about that a little bit. Some graphs are bad in the sense that they contain errors. Some graphs are bad because they are technically correct, but are misleading in the sense that the way the data is being represented could lead your viewer to an incorrect conclusion. So it's important to develop the ability to recognize bad graphs or deceptive graphs and to identify exactly how they are misleading so that you understand what the true takeaway is from the data. And you also understand to avoid these things when making graphs for your own data. Okay, the first graph I'd like to discuss is a scatter plot or a scatter diagram. So what this is a paired plot of XY coordinates essentially. And so the horizontal axis has your x-axis, and your vertical axis is your y-axis. And basically, this kind of graph is used to determine if there's a relationship between two variables. Typically, you're looking for a linear pattern in these types of graphs, and when there is a linear pattern, it shows that there's a relationship between what you're plotting on your horizontal axis and what you're plotting on your vertical axis. Again, the fact that there's a relationship between these two variables does not mean that they cause one another, but it does mean that there's an important relationship there that's worth exploring. So the graph that we're looking at here, we're comparing or plotting waist circumference with relation to arm circumference. And basically, the randomly selected males that were used to make up this data set, with this sort of linear pattern that we see, the pattern suggests that there is a relationship between waist circumference and arm circumference. Okay, another type of graph I'd like to talk about is a time series graph. And as the title somewhat probably leads you to believe, this is used for data that has been collected at different points in time. So this is time series data. So there's different types of studies where you may want to use this type of graph. So for example here, we have the yearly high values of the Dow Jones Industrial Average, or essentially the stock market, and you're plotting that based on years, and you're looking at the high. So you can see that in 1980, the highest it ever got to was probably about 1,000. And compared that to a high that we saw probably, I don't know, maybe 2006 or so, of 14,000. So it allows you to compare data over time like this. And you've probably seen graphs like this before. Okay, another type of graph is called a dot plot. And what a dot plot is it consists of a graph in which each data value is plotted as a point along a scale of values, and the dots representing equal values are stacked. So for instance, this would, and this is going back to our IQ score grouping. Now, if you'll look here, it means that one person scored a 50. One person scored probably a 56 or a 57. And in comparison with that, 3 people scored an 80. Now, I don't particularly find this type of graph to be all that helpful or something that a lot of people use on a regular basis. However, it can be helpful for showing your data in a different way. Another type of graph, another one that is not one of my personal favorites to use, but is something that's worth introducing to you, is called a stem plot or a stem and leaf plot. And what this is it represents quantitative data, so numerical data, by separating each value into 2 parts, a stem and then a leaf. And basically how you read this is that the lowest IQ scores are 50, so 50, and 56. And in contrast, the highest score is 141. The next highest would be 120, then 125, 128. So again, another way to represent data somewhat similar to a dot plot, although conceptually put together a little bit different. But again, not one of my personal favorites as a go-to graph for displaying data. Okay, we talked about histograms, and essentially a histogram is really a type of bar graph. So let's talk about bar graphs a little bit. In bar graphs, we use bars of equal width to show frequencies of either categorical, which is named data, or qualitative data, which is numerical data. The vertical scale represents frequencies or relative frequencies, and remember, all a relative frequency is the same data just represented as a percentage. And the horizontal scale identifies the different categories. There can also be a multiple bar graph, which has 2 or more sets of bars and is used to compare 2 or more data sets. So let's look at an example of that. So here's a multiple bar graph. So here we're looking at median income by gender. So you'll see that there's 2 different sets of data because they're comparing data from males to data from females. You'll notice along the horizontal axis that we have the years, so they're comparing this over time. So in 1950, this was the median income here. So it was, looks like about $3,000. Oh, I'm sorry, lost my slide. Okay, getting back. Whereas comparatively, and you can see that the gap between is relatively small. And we can see that over time, that gap has grown and grown and grown. Now, certainly, incomes have also increased greatly. In 2010, the median income for a male was $33,000, but the median income for a woman was only about $21,000. So again, these types of graphs, especially multiple bar graphs, are used to compare data from 2 different sets. But essentially, they're constructed like histograms. Okay, this is actually one of my favorite types of graphs, and that probably is because I work in manufacturing. And so this is kind of a favorite within that industry in particular, but certainly it could be used for other applications as well. This is called a Pareto chart or a Pareto graph. And what a Pareto graph is it's a special type of bar graph used for qualitative data, so you only want to use this with numerical data. And the bars are arranged in descending order according to frequencies. So let's look at the example we have here, and then I'll give you an example of how I've used this type of graph in the past. So this is a Pareto chart where we're looking at what contributes most to happiness. Here we have the percentage of people that said that whatever category contributed most to their happiness. And we can see that the first category is family and partners. This was the one with the highest frequency, so it was plotted first. Then friends, although quite a drastic difference in terms of the percentage frequency, but friends would be next, then leisure, then work, and leisure actually look about the same here, music, and finally sports. So it's actually in descending order. just like the definition says. So you may ask yourself, okay, how would Stacy have used that in business? So one way that I've used this in the past, and again, I work in quality, is to try to determine what the common mistakes are that are occurring and creating quality issues within our products. So let's imagine that we have 10 different defective products that get produced in a week at my factory. And out of those 10 products, 8 of them are because there was ink spilling. One of them was operator error. And one more was a machine breakdown. You would plot those in descending order again, and what it would tell you is that your highest frequency one is the main cause of your defects in the plant. And so you choose to look at ink spillage first and figure out, okay, that's causing the majority of our defectives, so that's where we're going to spend our time focusing on improvement as a company. So Pareto charts can be good for prioritizing and for a number of different ways. And so for that reason, in business anyway, Pareto charts can actually be really helpful and are pretty commonly used. A familiar type of chart that I'm sure many of you have made yourself, but certainly you've seen before, is a pie chart. And all that is it's a circular graph that represents your qualitative data as slices of that circle or the pie, in which each slice of the pie is proportional to the frequency. So looking at the same data that we had for our Pareto chart, but churning that data instead into a pie chart, it looks like this. So families and partners contributed most to happiness, friends, and then so on. And for some people, a pie chart is really easy because it's similar to percentages in a way. We understand what one slice of pie means, and we understand what no slices of pie mean, and we understand what a whole pie is. And so based on that, we can guesstimate the proportion. So we'd say, okay, well, roughly this is 75% of the pie, so families and partners is probably about 60% of the pie overall. Frequency might be another 20%. Work and leisure together might be another, 10-20%, and so on. And so pie charts are very visual. They're typically very easy to read and are a good way when you're presenting to a large audience anyway of having a fairly uncluttered graph. Some of the graphs, because of all of the data that gets plotted on them and the fact that they include a lot of numbers, they can be a little bit busy. Whereas a pie chart can really be left very simple, and for that reason, it tends to be something that people use a lot. We are not going to talk about frequency polygons. This is what one looks like. However, essentially it's just connecting dots between data points, but this is not a graph that you will see frequently or use. Similar to a relative frequency polygon, similar to what we've talked about before, a relative frequency is simply your frequency turned into a percentage. And so it's very similar to what you see in a frequency polygon. Again, you're just kind of drawing lines between different plotted frequencies. But in this case, it's in percentages. But this is not a common graph that you will use. Again, another graph that we're not going to spend any time on is an ogive, and that's a line graph that's meant to depict cumulative frequencies. Cumulative frequencies are not something that is very helpful in general as a concept within statistics. We talked about it very, very briefly in section 2.2, but as I mentioned there, it's not something you'll use often, and so based on that, you're not going to use this type of graph frequently either. Okay. So now that we've talked about some different types of graphs, let's talk about some graphs. And mind you, all the graphs that I previously showed you, going through each of the types, would be considered a good graph. They're graphed properly, the data is represented properly, and the person who put them together doesn't appear to be playing any funny games. Now, let's talk about some graphs that cannot be said for, and we'll talk through some ways that people sometimes manipulate their graphs to try to drive home their point, but in the process, they're actually putting a deceptive quality into their graph. So the first way that graphs can be deceptive is a non-zero axis. So what I mean by that is this. We're talking about this axis right here, your vertical axis. Now you'll see in this first graph that it doesn't start with 0. It starts with 30. Whereas in this graph, it starts with 0. Now let's look at these two graphs and combine them, and compare them rather. Now you'll see in the one where your starting value is 0, the differences look very minimal. So for the car company that paid for this study, it may not be enough to persuade the average consumer that a Honda Civic is worth purchasing versus a Toyota Camry based on gas mileage alone. Now, when they change the axis, however, to really only highlight this small section of the original graph and change that axis from 0 to 40 miles per gallon to 30 to 36 miles per gallon, the difference looks drastically exaggerated. And so what a non-zero axis graph is it's a graph that can be misleading because the axis begins with some other value than 0. And so differences are drastically exaggerated, and the careful, unless you're being careful when reading these types of graphs or looking at them, the average person may not notice that, and they may be persuaded to buy a Honda Civic based on this type of graph, when in reality, if they had seen this graph, they may have said, well, no, that's not so impressive after all. Another type of deceptive graph is what's called a pictograph. And essentially what a pictograph is, it's a drawing of an object. So some common ones that get used are money bags, stacks of coins, people, barrels, houses, those types of things. And these drawings can create false impressions that distort data. So let's talk about an example of this. So here's an example of a pictograph. So here you have income and education. So looking at a high school diploma and comparing that with an advanced degree, and they've used this dollar bill and this bars here to try to represent or somehow visually in a picture show you that an advanced degree is going to pay a lot more in the future. So in this graph, the bars all have the same width. It's a very busy graph, and it's actually difficult to understand. Here's another version of that similar graph. This is another misleading graph. Here, instead of using a dollar bill, they've used a box with a dollar symbol on it. So no high school diploma to an advanced degree. So this is depicting one-dimensional data, the dollars, with three-dimensional boxes. And it's important to note that the last box is 64 times as large as this first box, but the income difference is only about 4 times as large. And so looking at just the pictures alone, it can be deceptive. And that's the reason that pictographs are really not the best way to represent data, and certainly in a professional setting, not one that you see frequently. This would be an example of the way you'd want to represent income and education. You'd want to use a bar graph, like we've seen earlier, where you have the different categories, no high school diploma to advanced degree, annual income on your vertical axis, and each one plotted in a bar chart. This is fair, it's objective, and it doesn't have all kinds of distractions meant to potentially mislead people. Okay. A couple of principles that are suggested by a statistician called Edward Tufte related to this subject. For data sets that are very small, which he defines as 20 values or fewer, a table really should be used as opposed to a graph. A graph should make the viewer focus on the true nature of the data and not on other eye-catching or distracting design features. As a researcher, you should not be distorting data. You need to construct a graph that reveals the true nature of the data itself, not trying to mask that nature through a lot of distractions. And almost a good rule of thumb is almost all the ink in a graph should be used for the data, not for the design. So those are some basic principles to keep in mind with relation to graphs and being sure that you're making graphs that are not misleading. Okay, that ends section 2.4 on graphs that enlighten and graphs that deceive. That wraps up our discussion on chapter 2, and up next we will be starting chapter 3.